Okay guys, this is going to be a quick overview about how to solve some of these probability type problems in genetics. And we're doing a dihybrid cross here. Dihybrid means we have two different traits that we're looking at. In this case, I'm giving you a phenotype. So we did the other one in class, but these are the last four problems, practice problems. And at the end of this, I'm going to assign some other practice problems. I want you to try to apply this now that you've gone through it. So we want to figure out what's the probability of heterozygous parents for both traits. Eye color, which is the R's, and body color, which is the B's. What's the probability that heterozygous parents are going to create white-eyed black offspring? Now, remember, big B gives you a tan or brown body. Little b gives you a black body. Capital R, the dominant trait, gives you a red eye. Lowercase r gives you a white eye. Okay? So that's, oops, I spelled that wrong, didn't I? Okay, so here's how this will work. So white-eyed, what's the way to get a white-eyed offspring? Well, I can't have any capital R's. That means from this parent I need a lowercase r, and from the other parent I also need a lowercase r. To have a black offspring, it's also two recessive alleles, so I need both little b's. So what I need is I need this little b and this little b. I need this little r, this little r. What's the probability of that? So in this case, I need to take 1/2 times 1/2. Remember, if I need both to happen at the same time, that's an and. Right? I need this one and this one. Okay, and then so equals 1/4. 1/2 times 1/2 is equal to 1/4. You multiply across the top, you multiply across the bottom. 1 times 1 is 1. 2 times 2 is 4. The math is going to be the same for the little b's. You need this little b and this little b. So each parent only has one way to create that kind of offspring. They have to give them this little b and this little b. So what's the probability of having these two things? Well, I need to have little r, and I need to have little b to have the offspring be white-eyed and black. So little r is 1/4. Little b is 1/4. Because I need both of these to happen at the same time. This is an and problem, so I need 1/4 times 1/4. That's going to equal 1/16. 1 times 1 is 1. 4 times 4 is 16. And there's your answer. So with two heterozygous parents, 1/16 of their offspring will be white-eyed and black. We'll show both of the recessive traits. Okay? All right, let's try another one. Let's try red-eyed tan offspring. So, red-eyed tan. Okay? So how do I get a red-eyed offspring? Well, if we go back to our key here, red is created by the dominant allele, a capital R. So these offspring, or these parents, were both red-eyed and tan. They carried the alleles for black and white, but they were red-eyed and tan. So one way we can get that, red-eyed, is capital R, lowercase r. Or, another way that we could get a red offspring is if you have two dominant alleles, capital R, capital R. And for tan, it's the same way. Big B, little b will get you tan, or little b, or big B, big B. So how do we figure out these probabilities, right, for a red-eyed tan offspring? I can do the math the full way. I can figure out what percent of the offspring will be capital R, lowercase r. Well, that means I could use this R and this R, right? So this capital R from here and this lowercase r from here. Or I could use the lowercase r from here and the capital R from here. So that means 1/2 here. 1/2. 1/2. Actually, hold on. How do I want to explain this? Okay, let's think about it this way. Okay, so one way to get capital R, lowercase r would be if you got, it would essentially be the same math as up here. 1/2 times 1/2 would equal 1/4 for the capital R from one parent and the lowercase r from the other. If you got the lowercase r from one parent and the capital R from the other, so kind of switch that around, the math is the same. So ultimately what we're doing is we're saying, oh look, you have a 1/4 chance of this, 1/4 chance of the offspring being this way, so that means 1/4 plus 1/4, which equals 1/2. So half of the offspring will be capital R, lowercase r. Okay, because 1/4 of them would be the capital R from this parent and the lowercase r from here. Another 1/4 of them would be the lowercase r from this parent and the capital R from this parent. Combined, you have 2/4 chances, which equals a 1/2 chance. Now, you could draw the Punnett square out here, and you would see that there would be 2 of the 4 boxes would have a heterozygous offspring. Okay, convention says we write the capital letter first, but this is showing you kind of more where those R's came from. One came from the parent on the left, the other came from the parent on the top. Or vice versa, however you want to think about it. Okay, so that is one way. So half of the offspring could be capital R, capital R. Right? So capital R equals 1/2 of all the offspring will have a capital R, capital R. All right, let's now do the lowercase r, we'll have capital R, lowercase r. We'll be heterozygous. Now let's do the homozygous dominant. Capital R, capital R. Well, let's go look at the parents. You need this R and this R. That's a multiplication, right? So we're just going to repeat this math. Half of them, right? There's a 1/2 of a chance of getting a capital R from one parent, a 1/2 chance of getting it from the other parent, for a total of 1 out of 4 of their offspring getting both of those, because you need this capital R and this capital R. All right, so capital R is equal to 1/4 of the offspring will get that. Okay? Yes? So far, so good. The math for the big B, little b, or big B is going to be exactly the same. Okay? So we have another big B equals 1/4. The heterozygous parent, or heterozygous offspring, half of them will be heterozygous. Now, what I'm saying is I want to know the probability of all the ways I could get a red-eyed offspring and all the ways I could get a tan offspring. So 1/4 plus 1/2, 1/4 plus 1/2. Okay? So, and then on top of that, I need the red eyes and the tan to happen together. Okay, it's not an or, it's an and. They both have to happen. In this case, you take, you're going to take these and you're going to divide them up. So treat them separately, the way we've been doing it the whole time. So what's the probability of getting a capital R, lowercase r, or capital R, capital R? The probability then is 3/4. 3/4 of them will be this. So you have to make the denominators the same. You turn it into fourths. So 1/2 becomes 2/4. 2/4 plus 1/4 is 3/4. Same math here. Okay. So 3/4 of the offspring will be this. 3/4 of the offspring will be this. But that doesn't mean that 3/4 of the offspring will be red-eyed and tan. We need to multiply these two together because we need it to be red-eyed and tan. So the final math is 3/4 times 3/4, which equals 9/16. So if you take two heterozygous parents, the question of how many of their offspring will be red-eyed and tan is going to be 9 out of 16 offspring. That's the probability. Okay? Now you can turn that into a percent by dividing 9 by 16 and so on, but that's how you figure it out. Okay? One last one here and then you can do the rest. Offspring that have at least one allele for red eyes. Okay? So how do I calculate at least one allele? Well, do I care about the body? No. All I care about is having whether they have an allele for red eyes. What's the allele for red eyes? Capital R. Okay? So how many of the offspring will get a capital R? Well, half of them could get a capital R from this parent. Half of them could get a capital R from this parent. So it's 1/2 or, so they're getting this capital R or this capital R. Right? So at least one. So 2 would also work. So you could be capital R, lowercase r, or capital R would work, right? You'd have at least one allele. Okay? So we've already done the math for this, right? What percent of the offspring will be capital R, lowercase r? 1/2. Right? So we take 1/2 times 1/2 is 1/4, getting a capital R from one parent. Same. It's the same math. Okay? So 1/2 will be capital R, lowercase r. What about capital R, capital R? Well, we've already done that math too. Right? Because you need the capital R's to come from both parents to be this way. So 1/4 plus 1/2. Okay, so your answer here is that, oops, what's happening? Sorry. Is that 3/4 will have at least one allele for red eyes. Okay, and this is going to come into play later on when we're trying to figure out what's the frequency of particular alleles. All right, so that's some problems on how to solve them. I'm going to give you guys a few more to try as practice problems. Good luck. Let me know if you have questions.